An alkene is a molecule that has a carbon-carbon double bond. Let's go over the rules for naming alkenes. The rules for naming alkenes are going to be really similar to the rules for naming alkanes that you already are familiar with. So just like with alkanes, our first step in coming up with the name is to find the longest continuous chain of carbon atoms. So we're looking for the longest carbon chain. When we are naming an alkane, we just simply look for the longest carbon chain. But when we are naming an alkene, we are looking for the longest carbon chain that contains or includes the carbon-carbon double bond. So it might not be the longest chain of carbons in the whole entire molecule, but it absolutely must contain the carbon-carbon double bond. So when we look at this molecule over here, if we want to apply step 1 to naming this molecule, we need to find the longest carbon chain that includes these two carbon atoms and the double bond that connects them. So even though I know that you wouldn't consider this, this would not be an option for the longest carbon chain, because the longest carbon chain must include these carbons and the double bond. So for this particular molecule, the longest carbon chain is going to be a 5-carbon chain that looks like that. Once we have found the longest carbon chain, just like with alkanes, our next step is going to be numbering the carbon chain. When we number our carbon chain with alkanes, our goal was to give the smallest possible set of numbers to any substituents or branches that were attached to the chain. With an alkene, our goal is to give the smallest possible number to the position of the carbon-carbon double bond. So it doesn't matter where our substituents end up in terms of the numbers. We want to give the carbon-carbon double bond the lowest possible number. And this usually means that we want to start numbering the carbon chain from the end of the molecule that is closest to the carbon-carbon double bond. So for this molecule, we want to start numbering it from the right-hand side so that the double bond starts at carbon number 2 and continues to carbon number 3. If we numbered the other way, the double bond would start at carbon 3 and go to carbon number 4. Once we have the molecule numbered, the carbon chain has been identified, we can proceed with locating our substituents and naming them. And this we will do exactly the same way that we would locate and name substituents for alkanes. We will put them in alphabetical order at the beginning of the molecule's name. If we have 2 or 3 of the same substituent, we'll use Greek prefixes. Everything in this step is exactly the same as what you're already familiar with. When we put the molecule's name all together, we have to begin the name of the molecule with a prefix that would indicate the stereochemistry of the double bond if the double bond has stereochemistry. Right now, the only way that we know how to indicate stereochemistry of an alkene is with the prefixes cis or trans. So we will start the molecule's name with the appropriate prefix if applicable. Not all of our alkenes have stereochemistry, so this won't always be a step that we take. And then as just kind of as a note of what we're talking about with the prefixes, like I said, right now what we know is cis versus trans. And we are also going to learn another method, E versus Z. So we'll include that in the notes, but we're not going to talk about E and Z in this video. And let's go back before we continue on with our steps. Let's go back to this molecule and work on its name a little bit more. So we didn't do step 3, which was locating and naming the substituents. On this molecule, we have methyl substituents. We have 2 of them, so this is going to be a dimethyl, and both of them are located on carbon number 4. So in terms of naming the substituents, this is going to be a 4,4-dimethyl. Just in terms of the substituents. And then we can put the prefix, we can do step 4, put the prefix for cis versus trans. This molecule does have stereochemistry, so we do have to indicate the prefix. And let's put our reminder. Cis is when we have 2 substituents that are on the same side of the double bond. So we want to look at this side of the double bond. We want to look at this side of the double bond. We want to find something that is present on both of those sides. We have a hydrogen atom on both sides of the double bond. They are on opposite sides of the double bond. So this is trans. They're not on the same side, they're on opposite sides. So this is a trans molecule, trans 4,4-dimethyl. And if you are rusty on cis versus trans, just go back to some of the previous videos where we covered that. And then now we're ready for the parent name of the molecule. So the parent name is going to be based on the number of carbon atoms in the chain. This particular one is 5 carbon atoms, so its parent name is pentane. We are not going to call it pentane though, because pentane is the name of the 5 carbon alkane. To indicate that it's an alkene, we have to change the ending of the parent name from ane to ene, which makes sense because it's an alkene. So instead of calling this pentane, we will call it pentene. And last but not least, we have to locate the starting point of the carbon-carbon double bond. The carbon-carbon double bond spans 2 carbons, but we only locate from the first position. So for this, we will only use the number 2 as the location of the carbon-carbon double bond. And that location either goes in front of the parent chain, so it's in between the substituent and the parent. And actually, there's just really no room for that, so I'm going to rewrite it down here. We said this was a trans 4,4-dimethyl. The location of the double bond, the starting location of the double bond is carbon number 2. And then the parent name is pentane. Now, there is an option which students usually don't like to take. There's an option for step 6, and that is to embed the location of the double bond in the middle. Oops, I realized I made a mistake there. To embed the location of the double bond into the middle of the alkene's name. So that would look like this: trans 4,4-dimethyl pent 2-ene. And this is actually the newer method for naming alkenes. Most students and actually most chemists prefer the method where we put the location of the double bond in front of the name just because it sounds better and it feels better. There will be situations where we are going to have to embed the number in the middle of the name later on in the curriculum. It's not going to be necessary right away. But if you encounter this naming system, just recognize that it's just an alternative to putting the location in front of the name.